No, thank you, Doctor.
Thank you, Katie. So guys, so we said out of these 4 properties of gases, we already know that these 2 are inversely related. One goes up, the other one goes proportionally down. So the next study that we would like to do to find out the relationship between temperature and volume. Are these 2 related to each other? And if they are, what is the relationship between these 2? Again, we are keeping 2 of the other parameters constant. In other words, we keep pressure constant. And we keep number of moles, amount of the gas constant. In order to study relationship between pressure and temperature. So on this experiment, pressure remains P. Let's say P1 and P1. Pressure is not changing. Sorry, my slides are jumping again today. And we are not changing amount of the gas. We start with experiment number 1 at the temperature of 200 Kelvin. In this chapter, temperature is always using Kelvin. At a given pressure of P1, the volume is 1 liter. I'm going to change the temperature, double the temperature from 200 to 400. I'm increasing the temperature, keeping the pressure constant. See what is happening to volume? So this observation showed that if you increase the temperature, volume is going to increase proportionally, not inversely. While pressure and volume were inversely related, you see direct relationship. This means proportionality. Temperature and volume are proportional together. One is increased, the other one will be increased. Of course, only when amount of the gas and pressure is not changing. So this was a study by Charles, so it's called Charles' law. What does it say? When temperature of a gaseous system is increased, volume increases proportionally. Why do I say proportionally? Guys, what is relationship? What is the proportion? What is the ratio between volume and temperature in experiment number 1? Experiment 1. And experiment 2. The ratio between volume over absolute temperature is 1 over 200. And then experiment number 2, we are doubling the temperature. Doubling the absolute temperature. The ratio of volume over temperature remains 1 over 200. That means the ratio remains fixed. What ratio? V over T remains fixed. Let's say a constant. So that's what Charles says. It says pressure and temperature are directly related. So let's look at this experiment. We are running experiment at low temperature, so I'm going to call it cold. suppose this is 0 Celsius or 273 K. So we have this volume. We increase the temperature. Let's say this is 90 degrees of Celsius, where the absolute temperature is going to be 387 K. $363, right? If you add 90 to 273, what do you get? Did I get it correct? 273 plus 90, go back, plus 90. 263 is the temperature. So what did I do? I increased the temperature from 273 Kelvin to 363. What is happening to the volume? The volume is changing. So increase the temperature, volume will increase. That's what Charles law is saying. Of course, this is when pressure is not changing. And number of moles of the gas is not changing. So if I go to next slide, did I prove that ratio of volume over temperature remains the same? Charles law says, at a condition where pressure and amount of the gas is not changing, the effect of temperature, increasing the temperature will increase the volume, and the ratio between volume and temperature remains fixed. So how is this going to help? Well, you can predict the volume if you change the temperature. In other words, suppose we have temperature T1 and we have a volume of V1, and then we increase the temperature to T2, we can calculate the new volume of the gas. That's what Charles law helps us. In other words, guys, if you want to calculate final volume, when you make a change of temperature, could I use this equation? Can I use this equation to calculate final volume? In other words, in this equation, I give you the original volume, I give you the original temperature, and we change the temperature to a new temperature. Can I calculate, solve this equation for new volume? How would you solve this algebraic equation? Would you do cross multiplication? Would you say T1 times V2 is equal to what? V2 equal to T2 times V1? Simple cross multiplication. T1 times V2, T1 times V2 is equal to T2 times V1. Yes, cross multiplication is the easiest way of solving this algebraic equation. And if V2 is the unknown that you want to solve this equation for, what should I do? How do I solve this equation for V2? Can I get suggestion from anybody? Anybody?
You divide by T1.
Yes, thank you, Victoria. I can divide both sides by T1, so T1 and T1 are canceled. On the left-hand side, I have V2, and on the right-hand side, I have T2, V1, T1, which is the formula here. V2 is V1 T2 over T1. Guys, some of you may say, I don't like math, I'm not going to learn math. Right now, you probably shut down your brain. Don't do that. This is simple. And you have to use this in this chapter. So please make sure to come and give me a chance to do this with you during my office hours or during the lab time. There is lab time this afternoon from 12:30 till 3:20. So come and let's do this together if it doesn't make sense to you. So we can do well on this chapter. You need practice, come over, let's practice together. Okay. So this is a learning check. Go ahead, do the cross multiplication, do the same thing I just did, and now solve Charles' law for T2. Suppose V2, V1, and T1 are given to you. What is the value of T2? Go, guys. Good job, guys. Good job, guys. Did you get this? How did we do that? Well, we do cross multiplication. We do cross multiplication here, which means V1 times T2 is equal to V2 times T1. Your unknown here is T2. So you divide both sides by V1. Cancel V1, you're left with T2 is equal to V2 T1 over V1. Any questions? Please come and see me if these sounds difficult to you. All right.